Regarding advanced actions, we have several options to work with. The first is the anonymizer, which allows us to anonymize a field in the event so that the information contained in that field is not understandable by anyone. This is useful for sensitive fields that may contain confidential information. Another interesting one is the field generator. The field generator allows us to add fields that don't originally exist or aren't present in the data flow but are needed for some reason. If we go into it, we'll see it mainly includes operations related to dates, random number generation, and a custom field. The date-related options can be used to create time references, like calculating how much time has passed from one point to another. For example, the today and yesterday options generate timestamp data for 00 hours of today and yesterday, helping us understand how much time has passed since those reference points. The now option marks a timestamp at the exact moment the event is processed. This can be useful, for instance, to calculate how long it takes to process a piece of information. If we place a field generator at the beginning and one at the end, we can see how much time passes between 2 points. The random number option generates a number to help understand whether an event is processed one way or another. It can be used for testing or applying behavior based on randomness. The custom field lets us specify the name of the field we need and assign it a value. If we want to tag an event or add specific information, whether for writing to a destination or including some needed metadata, we can use this action. We can also specify the data type so that future actions in the pipeline can work properly with that field. The for each option allows us to process each event in a list individually, producing one result per item. The information is not grouped afterward. That would need to be handled separately, but each object or piece of data in the list is processed individually. We also have the ability to connect the Google Data Loss Prevention API in case we want to use this service from Onum. We can implement a kind of cache memory within Onum that writes to a Redis server. This action allows us to store information temporarily in memory, in this case Redis, so it can be accessed more quickly later. This means that in future events, we can check if that value has been seen before or not. If it has, we can retrieve and process it accordingly. If it hasn't, we process it as new. We can also write that value to the database so that our custom cache, so to speak, gets gradually populated with the data flowing through our pipelines. Finally, we have the HTTP request action. The HTTP request is an action similar to the HTTP sync, which we'll look at later. It allows us to make a request to a defined API or programming interface. We can choose the method and specify the URL. It's important to note that we can include parameters from the data flow in the server request. Although it may not be immediately obvious, we can write the names of the fields from the data flow using this format. For example, writing path, if path is a field in the data flow, we'll replace it with this value. This is how we access the value of a variable in the data flow. We would also need to specify the field containing the body, the JSON, or the data we want to send. We specify where the response will be stored, what headers to use. If we want to set a timeout, for example requiring a response in under 5 seconds, we can set a 3-second timeout. If it takes longer, we must cut it off. We can also specify whether to allow redirections and define the content type to be used. Authentication can be configured as well. None, basic with username and password, token-based or API key. Depending on the method, we'll need to provide the necessary information. We also choose whether to allow bulk configuration, how to store the data, and how many events to send per batch. We can also set a timeout to limit how long we wait before making a request. The number of requests per second can be configured. This helps prevent network saturation or overwhelming the destination, which might cause communication issues. Configure the TLS certificates for secure, encrypted communication. Enabling this unlocks the relevant options. If we set it to false, the options are disabled again. Lastly, we can configure proxy settings and retry behavior. This includes the maximum number of retry attempts, the wait time between retries in milliseconds, and the maximum time allowed between the first and the last attempt. This ensures we don't occupy a connection channel indefinitely or risk overloading the destination with too many requests. And that's it for the advanced actions.